Alrighty, we are in Notes 1 of Unit 1, talking about expressions. So these notes are pretty easy, they're pretty straightforward. Actually, this whole unit's pretty easy. Mostly what we're doing right now is defining some of the terms we're going to be seeing for the rest of the year. So I'm not going to be moving super fast, but it won't take us long to move through this. Make sure you're paying attention because on the back you're going to be doing a vocabulary match. Alright, well, let's get to it. So the most basic kind of math problem out there is called an expression. Expression. I'm going to go ahead and write some expressions here in the example, and I want to see if you can tell what makes an expression special. What makes it so simple? So I have 2 plus 2. It's a good example for an expression. I've got 3 plus 1 minus 8. I'm going to have the number 4. I'm going to do 22 minus 1. We'll do something like 10. And for fun, let's also do like negative 5 plus 7. Okay, what do all of these have in common? Well, the most important thing is that they all only have one mathematical idea. An expression only has one mathematical idea. It's just a thing. It's just one object. Now, an expression only uses numbers and operators. And when I say operators, what I mean is plus, minus, multiply, and divide. My operators are anything that changes numbers. What's crucial is that they don't have any equal signs. This is super important. Expressions don't have equal signs. That's what makes them an expression. So, if you notice here, none of these have an equal sign. It's just one mathematical idea that doesn't have an equal sign. Because of that, numbers by themselves can be expressions. So a number by itself can be an expression. That's like 4 here and 10 there. They're expressions because they're just a number. They don't have an equal sign. So, importantly, because expressions don't have an equal sign, they cannot be solved. You cannot ever solve an expression. Instead, expressions can be simplified. Basically, we take a complex expression and we make it simple. We simplify a complex expression. So, if an expression is not a nice and easy little number, we can make it simpler. That's why we simplify. Now, the work we show when we simplify looks a little bit different than normal. For example, 3 plus 5 can be a bit simpler. I can just write this as 8. I'm going to do all of my simplification work below the expression it matches. So 3 plus 5, I do a caret down, and I have 8 below it. 10 can't be any simpler. It's already as simple as it can be, so we're good. 2 plus 2, this can be simplified into 4. The number 4 is already set. This one here, it's pretty complex. We can make this more simple by combining 1 and 2. This gives us 3 plus 3 plus 4. Combine these gives us 6 plus 4. And then combine those gives us 10. Moving on, we can simplify 8 minus 16 to give us negative 8. And lastly, combining these, I simplify by taking my work down. I have negative 1 plus 1. And our final simplification is 0. Now, I want to make sure you know, do not write an equal sign for any step of your simplification. Though we take it for granted, equal signs have a very special meaning in math. Basically, they say that two separate ideas are the same. We won't worry about that for now. We'll talk about it in part 3, because essentially, expressions are just one idea. They're not two ideas that are the same. So for now, just make sure to put all of your work below the previous line. no equal signs. All right, if we take a look at the back, you have a checking understanding. I'd like you to take the time to use this word bank and fill in all of these blanks here. You'll also have some expressions work to do, and I want you to make some of your own expressions as well. Once you're done, you can go ahead and take the formative and move on from there. Thanks so much, and I'll see you in the next one.